This is the story of NASA's Parker Solar Probe, a mission so audacious that it redefines our relationship with the sun. For the first time in history, a spacecraft is entered in the sun's atmosphere, pushing the boundaries of engineering and scientific exploration to solve mysteries that have puzzled humanity for centuries about the sun. The Parker Solar Probe's journey began long before its 2018 launch. In 1958, Dr. Eugene Parker, a pioneering solar physicist, proposed a revolutionary idea. The sun is not a static body, but an active, dynamic one. It continuously releases charged particles from its surface, forming what we now know as the solar wind. At the time, Parker's theory was controversial, even dismissed by many in the scientific community. But over the years, evidence gathered through observations and research confirmed his predictions. Yet studying the sun from Earth was like peering through a foggy window. There was only so much telescopes could reveal. To truly understand our star, scientists needed to get closer. So, first proposed the idea of sending a spacecraft to the sun in 1958, but we didn't have the technology to withstand the journey until the 2000s. Fast forward to the 21st century, when advances in technology and engineering finally made such an ambitious mission possible. NASA's Parker Solar Probe was designed to answer fundamental questions about the sun, its atmosphere, and its impact on the solar system. Launched on August 12, 2018, in Cape Canaveral, Florida.
10, 9,
9,
8,
7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the sun.
Spacecraft carries with a photograph of Dr. Eugene Parker, who predicted the solar wind, and a digital copy of his historic paper outlining the foundations of solar wind physics, and a memory card inscribed with the names of 1.1 million individuals from around the world. NASA launched Parker Solar Probe mission to touch the sun.
One of the major goals for the Parker Solar Probe mission is to fly through the solar corona. And we are doing that now. Parker Solar Probe is touching the sun.
After spending a few years spiraling closer to our star, the spacecraft has finally arrived. So what does it mean to touch the sun? To answer that, we need to look at the sun's structure. Unlike Earth, our sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface of the sun, but around the sun, it's bound by the sun's gravity and magnetic field. This material forms the sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the pull of the sun and gushes out into space as the solar wind. The boundary that marks the edge of the sun's atmosphere is known as the Alphen critical surface. But we didn't know exactly where this boundary was. However, for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses.
Parker Solar Probe flies close to the sun. It will fly through the solar corona. And it's just amazing that to observe that a spacecraft is flying through a structure that we can see through during solar eclipses. And it's just fascinating.
The first mystery is about the temperature. The corona is around 300 times hotter than the photosphere, the visible surface of the sun below. Secondly, there's a constant stream of particles flowing from the sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technologies. In April 2021, during Parker's 8th orbit around the sun, the spacecraft was about 20 solar radii, or 8 million miles, from the sun's surface when it crossed into the corona. This is a huge milestone. It took over 6 decades to come to this point. When Parker entered into the corona, its whisper instrument took these images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Solar winds are escaping from the sun's pull, and energetic particles are accelerated to half the speed of light. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. As the Parker Solar Probe dives closer to the sun, it faces an environment that seems almost impossible to survive. Scorching temperatures, relentless radiation, and high-velocity solar particles bombard it at every moment.
One thing we are looking forward to is when Parker Solar Probe flies through one of these huge CMEs very close to the sun and tell us how these solar energetic particles are accelerated to almost the speed of light.
So how does it endure the sun's wrath without melting? The secret lies in its revolutionary thermal protection system, a heat shield made of advanced carbon composite materials. This cutting-edge shield is designed to withstand temperatures of up to 1,400 degrees Celsius, 2,552 degrees Fahrenheit, keeping the instruments behind it at a cool operational temperature of just 30 degrees Celsius, 86 degrees Fahrenheit. The heat shield works like an umbrella, always oriented toward the sun to block the intense radiant heat. Its surface reflects much of the sun's energy, while the carbon foam core dissipates the rest, ensuring the spacecraft stays protected. Even the solar panels essential for powering the probe are equipped with their own cooling system. These panels retract behind the shield when the probe is closest to the sun, leaving only a small portion exposed to gather energy, all while circulating coolant to keep the system stable. And it's not just the heat. The probe also faces high-speed particles and cosmic dust, tiny fragments traveling at millions of miles per hour. Its armored design ensures it can endure these impacts while continuing to collect invaluable data. Before entering the corona, Parker had seen kinks in the solar wind, where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed.
The switchbacks are reversal in the magnetic field. The magnetic field will flip over itself in and out in a matter of seconds and minutes. What is important about them is that they will tell us about the origins of the solar wind and how it came about.
In 2021, the spacecraft finally tracked switchbacks to one of their origin. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. And here we see distinct cells of the sun. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Then scientists found that switchbacks from inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle, though. Exactly how they form is still unknown from the surface of the sun, the photosphere. Parker's solar probe on its latest flyby, December 24, 2024, ventured deeper into corona before it stopped sending signals to Earth with a speed of 430,000 miles per hour, 692,000 kilometers per hour. During this approach, the spacecraft came within just 3.8 million miles, 6.1 million kilometers of the sun's surface. The Parker solar probe has since made history as the fastest human-made object. To put that into perspective, at this speed, the spacecraft could travel from London to New York in less than 30 seconds. At this speed, the Parker Solar Probe spent approximately 8 to 10 hours traveling within the sun's corona during its closest approach. Then the mission operations team at the Johns Hopkins Applied Physics Laboratory received a signal from the spacecraft on December 26th, confirming its successful passage through this intense environment. Detailed telemetry data is expected to be transmitted back to Earth on January 1st, 2025. This data will provide deeper insights into the sun's behavior, enhancing our understanding of space weather and its potential impacts on Earth. Following this milestone, the Parker Solar Probe is scheduled for additional close flybys in 2025, with the next approaches anticipated on March 22nd and June 19th. These subsequent encounters will continue to contribute valuable information, further unraveling the mysteries of our closest star. By combining ingenious materials and precise engineering, the Parker Solar Probe has not only survived the sun's hostile environment, but thrived in it, sending back groundbreaking data that helps us unlock the mysteries of our nearest star. A feat of engineering brilliance, proving that even the fiercest challenges can be overcome with innovation and determination. Thank you so much for watching, and don't forget to join our community. See you in the next video.